Continuing with Homework 5, we will next open up RMC PFM risk. On the cover page, you can input project information. You can also input nodal descriptions. Whatever you input under the description for a node will show up on the header for the node in the corresponding node worksheet. Also on the cover sheet is a table to input elevations of interest, like top of active storage or the embankment crest. Inputs into this table will appear as reference lines on applicable plots. Moving to the hydrologic hazard worksheet. Here's where we will paste data from the RMC stage frequency distribution spreadsheet. Copy the entire first 6 rows of data, all the way down to the very bottom of the table, whether it's data there or not, and paste its values into cell C10. Next, input the peak stages used to evaluate the system response. These can be found on the homework file for PFM1. The pools are the same for all nodes, so we can copy the first set from node 1. The list of values is shown here. If you leave a stage out, you can always go back later and add stages, but they must always be input in order from low to high. Moving on to the Life Loss tab. First, input the exposure probabilities. Next, we are told to use a beta PERT distribution for the consequences. So we will select beta PERT distribution from the drop-down and click Execute. The table will then be set up for you to input your data. And paste its values in column D. Next, copy the rest of the table. Once you paste the data in as values, the mean will auto-populate. Keep in mind different distributions have different inputs, so the tables will change based on the distribution selected. After copying and pasting, here's the completed breach life loss tables for day and night. After repeating the process for the non-breach life loss, you should get what is shown here. Next, we need to input the economic cost data. Copy the breach economic cost from the homework file and paste its values into the top table. Copy the non-breach values from the homework file and paste its values into the bottom table. From here, we are ready to input the nodal estimates. Each node worksheet is set up for a team elicitation. There's a drop-down at the top for whether the node is a failure or intervention node. In row 9, peak stages to evaluate are chosen. You can use the drop-downs in each cell to select a peak stage, or you can pull in all the ones input on the hydrologic hazard worksheet by clicking where it says peak stage. The pointer will turn into a hand when you are in the right place. So, clicking on peak stage brings in the stages we defined earlier. The table here is where the elicited values would go. Because we are given the final nodal estimates, we can scroll down to the next table where the consensus estimate is input. To populate this table, we will need to select a distribution, click Execute, and then input our data into the yellow cells. The homework file tells us to use a triangular distribution for each node. Select Triangular Distribution, Stage Dependent from the drop-down menu. Then click Execute to set up the risk calculation spreadsheet. The error will disappear and you will be set up to input the data. Copy the Node 1 data for PFM1 from the homework file. Paste its values into the table. Once the data is in there, the relationships will be plotted below. It is recommended to review this plot to make sure the relationship looks reasonable and that the probabilities change appropriately with stage. Scrolling down, there's another plot where you can view the probability density functions of the distributions estimated for each stage. Use the drop-down to the right to select the stage to plot. Repeat that procedure for each of the remaining nodes. Here's the Node 2 team estimate. For Node 3, be sure to select Intervention as the node type. Here is the completed Node 3 table. And finally, the completed Node 4 table. Once all the nodal estimates have been input, click on the Risk Calculations worksheet. The first table is the Team Elicitation Summary, which pulls in the data from the nodal worksheets. The next set of tables is where the system response probabilities are calculated. Use the drop-down to select an interpolation method. Because PFM1 is in overtopping failure mode, we will select linear. The next table in the worksheet is for the stage frequency. You will see the input data from earlier, the selected distribution, and a place for the output. The highlighted cells in column L will be blank initially because the spreadsheet's default setting is for a deterministic analysis. These values will populate when we change from a deterministic to a probabilistic analysis later. To the right, the user can specify if non-exceedance is to be included. It is included by default, and because we want to include it, we do not need to click anything. Scrolling down further, you will find the exposure and consequences tables. In row 411 is where you will choose the type of analysis, deterministic or probabilistic. You will need to have @risk installed on your computer and running to run a probabilistic analysis. To change the analysis type, the column in the stage frequency table I mentioned earlier will populate. Like we saw in the stage frequency distribution spreadsheet, the input and output expected values will not match or be close to one another at all stages until the simulation is run. The spreadsheet will automatically discretize the hazard into even intervals. You can override the stage partitions by editing the stages in the yellow cells under stage partitions, but the stages must be input low to high. From there, you are ready to run the simulation. The homework file tells us to use 1,000 iterations. After clicking Simulate, multiple dialog boxes will pop up. Click Yes for both. The simulation should take a couple minutes to run. Scrolling down and to the right, there are a couple tables where you can see the contribution of specific stage ranges. If you want to look at different stage ranges, you can choose from the drop-down, but stages must be ordered from low to high. The results will be plotted on the Simulation Results tab. To pull in the simulation data, click Plot Simulation Results near the top of the spreadsheet. The sidebar will turn red to show that the simulation results are populated. There are also several risk plots, including the FN scatter plot and simulation result statistics that you can explore.